We have a lot of things to get through today.
Yeah. Like you see that Linda. Oh no, this is gonna be bad.
Maddie. So just to make sure you guys are clear about this week, Zach, put it away. Today we're finishing up on the notes on 11.4. So it's probability of or statements. Tomorrow will be review. I've already put the review assignment in Schoology for those of you who wanted to try to start prepping ahead of time. Wednesday is day 1 of the test. Thursday is day 2 of the test. And then Friday is kind of intended as for if anybody's sick or something, then they don't have to take the test after spring break. Like, I definitely don't want to have to take a test on the last, or I don't try to plan to take a test on the last date because that just doesn't work out well. On the back calendar, I had it written as 2 days of review and then the test on Thursday. But that was before we decided to make the test over 2 days so that you wouldn't be super rushed. So we have the test split up so that it should easily be able to be done each day. And I know for those of you who are those of you who are leaving early have been figuring that out with me too. But yeah, it's definitely in 2 parts. Before we go over the notes, I wanted to go over the answers for these Venn diagrams though. So I told you guys I'd put these up today. And then I have a different, by the end of the day, we came up with a good way to explain it. And honestly, I'm kind of annoyed at myself that I didn't remember. I've explained it this way in past years. And for some people, it was a lot easier. So I can show that too. So here's the first 2 answers. So this is question 1 and 2. Now, maybe what I'll do is on question 2, I'll show you the other method. Because if I remember correctly, question 2 and then, was 3 the first one with parentheses?
Yeah. Mm-hmm.
So parentheses is where some people started to feel like they were having difficulties because they were, just trying to do lots of things in their head. So this other method might be good for you if you are a person that doesn't like the shading way. Because it was clear when we were doing these in class that some people, the shading method didn't click with them. So let me erase the second one and then show you the other method. So the other method, rather than using shading, uses numbers. So this is section 1. Because like if you look at this picture, there's not many sections. Like there's not many choices for things. This is section 2, 3, and then 4 would be where they have in common. Right? Let's look at A. Oh, I erased the A and B, didn't I? This is A, this is B. So if we look at section A, what numbers represent section A? 2 and 4. The A circle is made up of 2 and 4. B is made up of 3 and 4. B prime represents the opposite of B, or outside of B, which instead of 3 and 4 would be 1 and 2. So 1 and 2 are not B. The union symbol means that you are going to combine things together. So if I have sections 1 and 2 put together with sections 2 and 4, that would become sections 1, 2, and 4. If you put together 1 and 2 and 2 and 4, you get 1, 2, 2, 4. And so your final answer would be made up of sections 1, 2, and 4, which is the shading that I had that I erased.
Can you explain like B prime?
So B is that circle with 3 and 4. B prime is outside the circle, which is 1 and 2.
So everything that's not B.
Everything that is not 3 and 4. Yep. So if this numbering section makes it easier for you, I can certainly show you more of this tomorrow, like during our review day. Because if the shading method just didn't click for you, and so for some people it just doesn't, this is a good alternative way that is very different, but may make more sense. Okay, but either way, I'll just put up the rest of the answers. I won't necessarily go through them with this other method. So here was question 3 and 4. Obviously, I spent a lot of time this morning shading nicely, but I figured it would work for answers. Trying to get a lot of things in a couple days. Yes, ma'am?
Can you just explain how you got number 3?
The green one?
Yeah.
So A union B would mean that it was the combination of both circles. So that would be, well, basically everything that's white up there. The prime symbol outside of that means everything outside of that answer. So if your answer inside the parentheses was both circles together, the prime symbol would mean whatever is outside of both circles together. And if you want me to write the numbers as these sections, I know I said I wasn't going to do this. 1, 2, 3, 4. A is 2 and 4. B is 3 and 4. If I combine 2 and 4 and 3 and 4, I would get 2, 3, 4. And the prime outside of that would mean any number that is not 2, 3, and 4, which would be 1. Jack?
Could you explain 4, maybe?
Yeah, definitely. Sure. A intersect B means what do A and B have in common, which is this little sliver in between them. So A intersect B means what do circle A and circle B have in common. A union B prime was this green answer. That's why that was written right before question 4. So I'm essentially taking this green shaded answer and this little almond-shaped section in between them, and then the union symbol means to combine them. So it's the combination of the outside shading plus the inner shading. With the numbers, Maddie. So do these numbers show up okay on top of the black? Okay. So A is 2 and 4. B is 3 and 4. The intersection means what do they have in common? So just 4. So 4 is just in common. A union B is the exact problem on the left-hand side. So 2 and 4 and 3 and 4 combined together would be 2, 3, 4. And then the prime symbol means outside of 2, 3, 4, which is 1. So then your final answer would be 4 combined with 1. Yeah, that's why I said, for whatever reason, like if somebody's not very visual, like the graphing way makes it really difficult for them to picture things. But assigning it with numbers kind of makes it so you, like logically it makes sense. Yes, ma'am.
Why would you fill in, why would you need 1 for A and B? Because, oh, is it everything but?
Correct.
Oh.
AUB would be everything on the inside, and then the prime means opposite of that. This is question 3 and 4, I think. So here's 5 and 6. 6 was kind of weird because I think some people doubted themselves, like they felt like that couldn't be right. If you combine B along with everything that's not B, that should make up everything.
Oh, can you explain the 5?
Is that the red one?
Yeah, because I should, like, the 1, like I should outside
Gotcha. You liked the number way better, it looked like?
Yeah.
Okay, I'll try to explain it that way then. A would be 2 and 4. B would be 3 and 4. But B prime means everything outside of B, which would be 1 and 2. And then the intersection symbol means what do they have in common? So what do 2 and 4 and 1 and 2 have in common, which is just 2? And then the last two questions, A union B, probably was like the easiest one on this whole thing. I don't know why it was question 7. I feel like something got erased on question 7 because that was pretty easy. But whatever. Having an easy one in there is nice too. Yes. So B intersect with A union B. A union B would be both circles together. B is just the second circle. And so the intersection symbol means what do they have in common? So the first one is just the second circle. The second answer is both circles. So in common would be just the second circle. Yes?
What numbers are those?
7 and 8. All right, Maddie, here you go. I could tell by me trying to explain it out loud didn't really click. B is 3 and 4. A is 2 and 4. B is 3 and 4. A union B would be putting together 2 and 4 and 3 and 4, which would give you 2, 3, 4. The intersection symbol means what do 3 and 4 have in common with 2 and 3 and 4, which would be 3 and 4. Yeah. Wednesday and Thursday. I believe it's mixed together. I'll double check. But I believe it's mixed together. Okay, so those were just the answers from the homework. Now the notes. Normally I have you guys copy down notes, and I kind of wait for you to write things down. I don't feel like we're going to be able to do that today. Only because we've got a bunch of problems to get through, and I mean, like, there's a lot of writing, so I don't think it'll mesh together. So we'll kind of just go through them today, and if you guys want to copy down the notes, I will have them. I can't remember if I already put them in the folder. I don't think I did yet. So I will have the notes for you so that you can copy down the notes. If you like some people, writing it down just helps them remember things. And that's normally why I would absolutely dedicate the time to it. But today feels like it's just too much to fit in with the writing. And since we don't have a choice on Friday being the end of the trimester, I don't really have a choice to give you more time. Now, this is something we have talked about before. I can't remember if I used these words. I think we called it independent, dependent for the most part. You guys are just in habit. You're just writing it down. Well, you can. I'm just not going to wait for anybody to write things down. All right. Oh, that's fine then, as long as you guys understand that. So mutually exclusive is when two things that can't happen together. So like rolling a 1 and a 2 at the same time on a single dice. Can't happen. That would be mutually exclusive. Now, you could say rolling an odd number and a multiple of 3, right? Like that could happen at the same time. And that wouldn't be mutually exclusive. But two things that are the same, their Venn diagram would look kind of weird because it would not overlap. The way that you find the probability of things that they don't have in common, I'm going to post a note. That's why I'm not going to be able to wait today. I know it feels weird. It's just like habit to. The probability to find mutually exclusive things is you are going to add them together. Mutually exclusive is keyword for or. So if I'm trying to find the probability of A happening or B happening, because they can't happen at the same time necessarily, then I'm going to add their probabilities together. All of these formulas will be up on the whiteboard during your tests. You are not going to need to memorize the probability formulas. So here's an actual example. A drink company applies one label to each bottle cap, which I don't think they really do this anymore. A lot of companies actually used to do this, where they would have free drinks and things in the, like you'd look at the bottle cap and it would say free drink, or like McDonald's. I don't think McDonald's has done the Monopoly thing for a while, have they? They used to do the Monopoly thing where you'd peel off on the cup and it would say free meal or free drink or free fry, something like that. That's kind of what they used to do with bottle caps of drinks. And I don't think anybody does that anymore. Snapple's like the only one I can think of that writes something on the cap, and it's usually just some kind of weird sentence, weird phrase, isn't it? Does anybody even drink Snapple anymore?
Real facts. Snapple real facts is what they call them.
Actually, Snapple doesn't use the glass bottles anymore either, I don't think. So they might not even print it on there. Whatever. Got off track. A bottle cap has a 1/10 probability of being a free drink and a 1/25 probability of being labeled free meal, which, let's be honest, it's kind of weird to be a free meal if it's buying a drink, but what is the probability of getting a free drink or a free meal? Now, what you need to think to yourself, this is an or statement. So most definitely we would start off, when we're writing this down, free drink or free meal. So I can't talk and write at the same time. On an or statement, the main thing you have to figure out is if these two things can happen at the same time. In this case, they definitely cannot, because you can only open one bottle cap. So your bottle cap is just going to say one thing. It can't say both. And so that would mean they're mutually exclusive. Because of that, we automatically are just going to add their answers. So probability of free drink plus probability of a free meal. We were already directly told their probabilities in the problem. So this isn't something you have to figure out. Free drink was 1 out of 25. Free meal, oh, backwards. It's nice. Free drink was 1 out of 10. Free meal was 1 out of 25. And then you would add those two answers together. I'm going to make this decimal because, not that those are horrible fractions, but 1/10 is 0.1. 1/25 is 0.04. So it would be 0.14.
On the test, can you make the fractions decimals to make it?
Correct? On the test, you are allowed to use fractions or decimals or percents at any time. I will understand any one of the answers, so I'm not too worried about it. Whatever makes it easiest for you is I'm good with. Okay, now mutually exclusive is by far the easiest thing because you just add together the answers. The ones that take up more time, possibly more thinking, are inclusive. I mean, if you want to say mutually inclusive, go for it, but. So, mutually inclusive is when those two events have one or more outcomes in common. So there's a Venn diagram up there, which is why we started with Venn diagrams. Like a lot of these, a Venn diagram is easiest to display the info. Even numbers and prime numbers. They do have one number in common. So obviously even numbers would just keep getting bigger past 6, but that doesn't matter. And prime numbers, the example up here obviously is just those. So, but prime numbers, 2 is the only prime number that's even. And that's because every number that's bigger than 2, when they're even, you can always cut them in half, and so they wouldn't be prime. 2 is the only one that 1 and 2 are the only factors that's even. So in this case, where'd that pick? I guess I don't have anything written with that. If we were to do the probability involving mutually inclusive, the way that you're going to set it up is you are going to add their probabilities separately, but you don't want to count the information that's in common twice. Like if I added the probability of evens and the probabilities of primes, the number 2 would be included in both of those answers. And so we have to subtract and remove off the common information so that it's not counted twice. When I write these formulas up on the board, I'm going to try to write a short description with it. I'm obviously not going to be like writing a million things there to just tell you what to do, but I'll do my best to try to, like 2 or statements. They both just say probability of A or B. And so you have to know the difference on which one to use. It's just like when we did AND statements. So we'll go with cards because generally cards you guys have played with enough that you kind of mentally can picture them. So it says a card is drawn from a deck of 52. What's the probability of drawing a red card or a face card? Now we're going to use a Venn diagram to try to set this up. On the test you don't have to, but I know a lot of people that need to. Now I don't know how many of you knew that a deck of cards had 52? I bet some of you know that and some of you don't. Okay. I always know that because I always had siblings who thought it was funny to play 52 pickup. And does anybody have to play that game? Yeah. So it's usually when you have older siblings. And they find it funny that they ask you if you want to play a game, right? Ask if you want to play 52 pickup. And so then they take a deck of cards and throw it on the ground. And that's 52 pickup. And so I always know how many cards are in a deck of cards because that's the name of the game. So drawing the Venn diagram, what I'm going to do is I'm going to draw the first set of outcomes. Drawing a red card, hearts or diamonds. Okay, well, I suppose I should put it in red. Hearts or diamonds. Now, obviously I just drew symbols. How many cards are hearts or diamonds? Well, it's half of them. There's 4 suits and cards. 2 red, 2 black. So half of 52. Oh my, this isn't going to... 26, okay. 26. There are 26 cards in half of a deck. Face cards are jacks, queens, and kings. Do you guys know how many jacks, queens, and kings there are? Do you guys not really play cards at all? 12. There's 4 of each. There's 4 jacks, 4 queens, 4 kings. So there are 12 of them. Now, what do I put in the middle?
The reds?
No, actually, outside of the circles would be ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the middle is going to be the red face cards, which would be the jack of hearts and diamonds, the queen of hearts and diamonds, and the king of hearts and diamonds. There would be 6 of them in the middle. So once I write this 6 in there, that means that there are 20 out here. Well, I'll back up. I don't want to write that. I saw some confused looks. Are you guys okay with me crossing this out and writing 20?
Yeah.
26 would be how many cards are in the complete circle.
I'm just confused with like where you got 6.
Yeah.
I don't know where you got that.
The red face.
So the first circle represents red playing cards. Second circle represents the playing cards that are jacks, queens, kings.
And how did you know those numbers?
You just know what's going
Play cards.
Well, when I like it, so obviously know.
Cards is supposed to be like the most common thing ever. Don't you guys ever play solitaire even?
Yeah, I do play cards. I just don't really know.
Holy man.
If I like took my time to count, but I don't remember.
I won't do
But I do like playing cards.
it. Like I'll have to throw it out.
Hold on. So this is just jacks, queens, kings. There are 2 black jacks, 2 black queens, 2 black kings. There are 2 red jacks, queens. This is jack of clubs, jack of spades, jack of hearts, jack of diamonds. I mean, like, I'm not trying to tell you to gamble more, but man,
Pick up a deck.
just play solitaire at least. Then you at least know the cards. Oh, okay. There are 12 of them. These are all 12. This section in the middle represents how many of these face cards are red. So the first circle represents red cards. Second circle represents face cards, which I drew all 12. This piece in between represents which cards are red and face cards. Thank you. So I'm going to leave it like this so that I don't super confuse you more. I should cross this out and write 20 instead, but I'm not going to because I think that'll hurt you. So the probability of a red card or a face card, the probability of a red card plus the probability of a face card minus the duplicate ones, which is the probability of red face cards. Now, I could write red intersect face. I think this would be easier for you to follow for right now. There are 26 red cards that we mentioned out of 52 cards. There are 12 face cards out of 52. We need to subtract the ones that are counted twice because there are 6 cards that were counted in both categories. I'm trying to think of a different topic that we could use instead of cards, but like cards has always just been a traditionally really easy one because it's something that most everybody has done. I mean, I get it, some families don't really play a lot of cards. I guess you guys just go on your phones now instead of playing solitaire on the computers. That used to be the only game on computers, Minesweeper and Solitaire, so that's what everybody was expert at. So this would be 26 and 12. 38 minus 6 would be 32 out of 52. Now, there is going to be lots of other examples that's not cards. So it's not like every single question is going to be card. Get off your phones. That's not going to make it any easier to understand. Like, I get how you guys have questions on it, but Do you want me to not do this one because it's a card one, or do you definitely want me to because you need more examples of cards? Okay.
So you said there's gonna be card questions on the test.
Well, yeah, because that's usually an obvious one that's usually most people haven't. Usually most people can visualize these because they've played cards, so they recognize them. Maybe what I can do is put up a deck of cards on the whiteboard during the test. Would that be helpful? All right, I'll see if I can find a diagram of a deck of cards. Okay, let's do the probability of a king or heart. Well, first thing we need to do is figure out, do they have any information in common? So on the left, I'm going to write the kings. There are 4 kings. King of clubs, spades, hearts, diamonds. There are 4 of them. On the right are heart cards. There are 13 of each suit. I definitely, now that I'm saying this all out, I definitely will put a picture up of cards. Okay. Is there any cards that are a king of hearts? That's what you would need to try to figure out if they are in common. There would only be one of them. There's a single card that's in common, the king of hearts. So because they have common information, these are not mutually exclusive, these are mutually inclusive. So the answer would be the probability of kings plus probability of hearts. Maddie, get off the phone. Minus the probability of king of hearts. So the only difference between these two formulas is if they have nothing in common, you just add them. If they have something in common, you have to subtract it at the end. Both formulas are the same, minus this addition. Technically, this same formula would work for when they have nothing in common because you would subtract nothing. So probability of kings. There are 4 kings out of 52 cards. There are 13 hearts out of 52 cards. We are going to subtract king of hearts, which is 1 out of 52. Now, I mentioned before that technically this Venn diagram is wrong. I think for some of you it would be helpful to write it like this, but this is actually wrong. Like, do you guys know why this is wrong, the way I wrote this? Because the way I wrote this, if I look at the king's circle is made up of 5 cards. So when you put stuff in the middle, you're supposed to subtract on the outside, but I think for some of you this might make it more confusing. So if this is more confusing, just set it up however it's going to help you. Like, you're not going to have to draw the diagram. Actually, I better check the test to double check. I'm pretty sure that you don't have to draw the diagram to answer any of these. It's just there to help you, but you don't have to draw it. So would that be 17, 16 out of 52, which does reduce, but to something, I don't know. Okay, non-cards. Yes?
For questions like these, do you want the answers to be simplified?
Yes.
Yes.
Although, now that I say that, I don't know if I'm actually going to, take points out. Just because we've got so many different kind of questions on this test that I feel like that might be overkill. Yeah, that'd be perfect. Okay, out of 1,300, okay, let's read numbers better. Out of 3,510 drivers surveyed, 1,950 were male and 103 were colorblind. Only 6 of the colorblind drivers were female. What is the probability that a driver was male or colorblind? So, this one's got a lot of different numbers up there. And this is where the Venn diagram would probably be helpful. It's to organize your numbers. So I'm going to focus on the fact that those were the 2 topics being asked to find. What's the probability a male or colorblind? So that's what we're going to try to draw. So males, colorblind. It directly tells us how many were male. Like that part's pretty quick and easy. It does not directly tell us how many were colorblind. It doesn't. So, I take that back. It does tell us how many overall people were colorblind. What number should I write in the middle? Maybe that's what I'd be easier to ask. It's not going to be 6. So this is what I was trying to say when I said it doesn't directly tell us.
97.
Where'd you get 97 from? Just kidding?
Yeah. Forget I said that.
What? It wasn't wrong.
Was it right?
Yeah?
Oh, yeah, it's subtractive.
Well, why'd you doubt yourself just because I asked?
Yeah.
Oh. When it tells you that 6 were female, we're specifically trying to find out how many of the males were colorblind, because that would go in between the 2 circles. So if you have males colorblind, the middle would be colorblind males. But in the problem, it tells you 6 colorblind were female. So that would kind of tell you that 97 were male. Now, I don't know if there's any science people in here. Are males that much more likely to be colorblind?
Yes.
Really?
Colorblind.
That's kind of weird. I didn't know that.
I think it's to do with like the genetic markers on
Huh. I definitely did not know that. That's weird. Now, if I were doing these correctly, I would subtract 97 from both of these. So I'm going to leave it as is for now, because I think for some of you it'd be easier to write out the answers. But this Venn diagram technically isn't right when I leave 1950. So I'm going to have to find the probability male plus probability colorblind minus the probability of a colorblind male. Ouch. Hopefully it didn't break. So probability that they were male is 1950 out of, what do I put it out of? 3510. It does tell us how many total there was. Probability colorblind was 100. Yep, I started writing letters there. 103 out of 3510. And then we'd have to subtract off colorblind males because they were counted twice in this setup. So 97 out of 3510. I don't know what that comes out to off the top of my head. But if you were drawing the Venn diagram correctly, you would have to subtract 97 from this and 97 from this. Yes.
So you would add the 103 and 1950 and then subtract 97, that's your
Answer.
answer?
Yeah, so when I was writing these numbers, these were probabilities because we were trying to look for like desired outcomes out of total outcomes. And being male was 1,950 out of 3,510 people. So then that was the probability a random person would be male. Hi, thank you. I think this is my last example. No. Nope. Oh, sorry, go ahead.
Can you go back real quick?
I can. Wait, am I going back so you can finish copying it down?
Yeah.
No.
Okay.
So that's why I was trying to say at the beginning of today that I wasn't going to be able to,
Oh, okay.
but I do have the notes posted to be able to copy them down. So there are 5 students in a book club. Each student randomly chooses a book from a list of 10 titles. What is the probability that at least 2 students in the group choose the same book? I don't know if we have time to put this one in.
Yeah, we don't.
So much to do in one week. I think I'll stop here just because I know I don't have time to finish explaining this one. Now, I don't like doing that just because we're not going to have time to do this tomorrow. So, who asked about the homework again? I already forgot. Everyone? Okay. There wasn't a lot of homework tonight because I wasn't going to give you a separate assignment for or statements. I wasn't going to just overload you with homework during the week because a lot of you have other classes that you're working on too. So I'm kind of making the homework for 11.4 or statements optional. You are more than welcome to do some of them on your own because you guys have the PDF of chapter 11 already. And if you want to go into the textbook and do some of those questions on your own, you are more than welcome to, and I have the answers for them up there for you. Otherwise, I thought what most of you would do is just start working on the review for the test, which includes questions from or statements. And I have the review posted already. Actually, you know what? I think I have a homework assigned for 11.4, but I should probably just delete that. Because if I remember correctly, I don't think Schoology lets me make something optional without it looking like it's a missing assignment. Because I was going to put it in there and anybody who turned in an assignment, I was going to give them credit, but it looks like something's missing if I don't write something down. I'll leave it in there, and then I'm going to mark anybody who doesn't turn one in excused. So that way, if you want to turn an assignment in to raise your grade, you can. If you don't turn one in, I'll just mark it as excused. I know I don't even have anything written inside of it because it was just up to you what you wanted to work on. Okay.